I really love looking at the incidents that happen in the real world or to other services as a way to make my own services more resilient. Today, I'm going to talk about the DataDog outage that happened recently where they were down for about 11 hours. Obviously, a really bad thing. We don't really have the cause of error yet at the time that I'm recording. But what we do know is that it was an issue in their control plane deployment that caused all of their data plane clusters to lose connectivity. When I think about the large outages that I was part of or observed at AWS, a fair number of them were due to a control plane, and a fair number of those were due to a long outage in an underlying database. So let's talk about that. So one of the things people want to have a single database because it makes building your software easier, frankly, because you can query one place for all your information. Databases are very useful at that. But they do create they have a large blast radius when they fail. And they also often take a long time to come up. And when they due to crash recovery, and often when they come up, they take the response rates are slow because the cache hasn't warmed and, right? And so you run into those issues very frequently. And, all of your data is there, so you can't do anything unless it comes back. I wouldn't be surprised if, when we look at DataDog's incident report over time, it's related to some database schema change that they were doing. So there are a couple of techniques you can use. One thing is to think about a cell architecture where different people have different databases, so you can control the blast radius of a failure, right? So maybe some people are down, but not everybody's down. Obviously, those people are still having a bad day, right? So, but not everyone. So that helps you. The other thing I think is useful is to think about how to make database failures roll back. So, for example, a lot of the reasons people have long outages is because they make a schema change. People start making changes. It's hard to roll back because you have to go back to an old version of the database. It takes a long time. So instead, the question becomes, how do I turn that into a sequence of steps, each one being reversible? I'll give you an example. So let's say I wanted to change something from a number to a string inside some table. So you could just make that change, but then suddenly if there's a problem with it, it's hard to roll back. Instead, what I learned to do is I add a second column to that table. Then I make the change so that it's inserting into that first column as it was before, but not the second one. Then I make the change so that it's inserting into both of them, but it's still reading from the first. Then I make a change so it's inserting into both of them, but it's reading from the second. Then I make a change so that it deletes the old column that no one's reading from. So you can see that it takes a lot longer. It's like 5 deployments I just walked through there, but each one is easily reversible without impact. And that makes a big difference because then you don't have to be sitting there in the heat of battle with your systems down, trying to figure out how to get them back. You just roll back a deployment to a prior point in time. The other thing that's important about that is that, these are distributed environments. You have a lot of people, different services or different endpoints talking to that same database. And so it lets them act at different version numbers. You don't have to get everyone to a single sync point because the data is still accurate, whether you're on version N or version N-1 or version N+1. And so that makes a big difference as well. So, that's just a technique. I'm not saying that that's what happened to them, but it does help. The combination of making changes reversible in your data tier, reducing the blast radius of your data tier due to cell-based architecture really can reduce the amplitude and the duration of your failures. Hope you found that interesting. Love to talk more in the comments or on reliability.org, the Slack channel where we talk about these sorts of things.